It's important that you follow this link and have a go at this yourself before I go through these. So do that now if you haven't already. So in task 1, when you change the value of k, you should have found that this one here represents, using mathematical vocabulary, a translation by the vector. Let's try the word by the vector, and it goes up by k, so that is 0k. When you did this one, you should have found that this one does a translation as well. But this time, it is going, instead of up and down, it is going left and right. And it's not by k, it's by minus k, because when this is plus 2, it moves to the left by 2. So it is minus k, 0. So these transformations, when we're adding a value, are both translations. Putting this into practice, describe the transformation that takes y equals f of x to each of these. This would be a translation by minus 8 and positive 1. This one is the negative, this one is positive. This one is also a translation by the vector, or if it's minus 3 inside the brackets, it's a translation of 3 in the x direction, and then positive 5. Minus 1 becomes positive 1, and then the minus 6 in the y direction stays as minus 6. Write the equation of the graphs of these when translated by these vectors. This one is going to be f of x. Now the horizontal motion is by 1, so it becomes minus 1 inside the brackets. And then a vertical motion of 3 is plus 3. Horizontal motion of negative 2 becomes x plus 2. And a vertical movement of 4 becomes plus 4 outside. And for any general function, any general translation by vector AB, it's f of x minus a plus b would give that translation. If we move on to the next part now, again, have a look at task 2 and have a look at what happens when you look at these two transformations. And you should see that this one is a reflection, and it is a reflection in the x-axis. Now, I personally like to think of this as in the y direction, and we'll talk about why I think that when we come to the notes section of this. This one is also a reflection, and it is this time in the y-axis, or I prefer to think of it as in the x direction. So both these transformations, when we have a negative involved, are reflections. Can you describe the single transformation given by the graph of minus f of minus x? That's going to be a rotation by 180 degrees about the origin. If you have a look at what that looks like, you'll be able to see that. If we now look at what happens when we have something multiplying our function, as you play around with this in the Desmos activity, you should have found that this one, the function is sort of pulled upwards. Now that is a stretch. It is a stretch in the y direction, or vertically, and the amount that it is stretched by is a. So if a was 2, for example, it gets twice as high. If a was a half, it gets half as high. Now this one, when we play around with the value of a, you see that it also kind of gets pulled out or inwards, but this time in the x direction. So it gets wider or narrower. This is also a stretch, but it's in the x direction, and this time it's by a factor, and oh, sorry, that shouldn't say 2 there, that should say a, by a factor of, well, it's not a this time, because when it's 2, it gets half as wide. It's actually 1 over a. It gets stretched by the reciprocal. So when it's 2, it gets squished to become half as big. When it's a half, it gets stretched out to be twice as big. And these two are both examples of stretches. In the next video, in the notes, we'll talk a little bit more about each of these in turn and how they work and look at some examples.